Hello friends, this is ninth lecture of our data science using Python series. In this video, I will cover the topic of regression modeling. So first we understand that what is regression modeling. So regression modeling is a mathematical method that helps us understand the relationship between different data points and make predictions. For example, if we want to estimate something for the future, like how much a customer might spend per visit, we can see a regression model to find an approximate value here. So how do we estimate a regression model here? So our goal here is to predict a customer sales per visit based on their days between purchase and credit card use, whether the customer have a credit card or not here. So example, if if there is a customer who shops every 333 days and does not have a credit cards, we plug their details into the model. Using a formula, we calculate that their sales per visit should be around $128.13, but the actual amount they spent was $184.23. So here we have a prediction error here. So prediction error is nothing but it is a difference between actual sales and predicted sales. So it was a difference, actual sales minus predicted sales. Actual sales is equal to $184.23 minus predicted sales is $128.13 here. So it is total $56.10 prediction error. So model evaluation matrices. What is model evaluation matrices here? So model evaluation helps us understand how accurate our model is, where we have two important matrices. For model evaluation, two important matrices are used here. So first one is standard error of estimate. Standard or error of estimate means this predicts the typical error in our prediction. Here, based on our data, it is 87.54. This is quite large because our data is missing many details that could improve accuracy here. Next is mean absolute error. So, the mean absolute error is the average error between the predicted and actual value. Here our mean absolute error is $53.39, meaning that on an average there is a difference between $53.39 between predictions and actual values. I hope you all are understand. Next is what is R squared value. R squared value tells us how much of the total sales variation is explained by the predictors. Here two predictors here, days since purchase and credit cards. In our model, the adjusted R square value is 0.064, which is not very high. This means there are other factors affecting sales that our model does not cover here. So now next we understand with the Python code how we use it using coding. How do we estimate using coding? So this is a code of our regression modeling. Sample data of demonstrate assumes there's the feature array. Here two array I will create here. Constant credit card uses is a features error, and by is equal to targeted data array. Next is split data into training and testing set. So xtrain, xtest, bytrain, bytest, split our data. Next is linear regression model. So this is a method that create a model of linear regression, that is define the customer data and make prediction. So here is a predicted sales for customer 1, predicted sales dot 2f. By predicted on the test set and calculate mean absolute error here. So how can calculate mean absolute error? So this is a method mean absolute error that takes a two parameters such as by true is equal to by test and by prediction is equal to by prediction here. Next is the mean absolute error is representing the average error between predicted and actual error. So this is our output. This is not connected with Google Colab. So sorry, this is not connected with Google Drive. So this is, I will run the code here. This is the output of our predicted sales for customer $533.00 and mean absolute error is $25, representing the average error between predicted and actual value here. Next is, then the next topic here, stepwise regression. So what is stepwise regression here? Stepwise regression is a method to select the best predictive model by iteratively adding or removing features based on statistical significance. This approach refines the model by selecting variables that improve prediction accuracy. I hope you all are understand. Next is, I will explain with the code here. After that, we will compare the model. So this is the code of our model evaluation. Next code. It is create a model first here. Next, this is the code of our regression modeling, stepwise regression. This is the code. So this is the model creation code here. Next is, I will run this code here. pd.data is equal to pd.data frame. Here one error occur. PD is not defined, so here import pandas at PD. Import pandas PD. I will try again. Oh, so first we need to create a model. So I will run the code here. Yes, so I will run the code here. Next, I will run the code. Yes, so this is our predicted model and stepwise regression that gives an output of model, method, date, time, number of observation and all. So this is the report, output report of our stepwise regression. Next, we will compare the model. We will compare next. Example of compare models. So here we will compare the models, two models comparison. This is the code of two model comparison. I will run this code. Yes. So baseline mean absolute error is 87.50. Regression model mean absolute error is 12.50. The regression model performs better than the baseline model here. So this is the concept of our regression modeling, comparing regression modeling and stepwise regression. Thank you.